Hey folks, welcome back to part two of your 8.2 lecture video. And so in this video, we're going to talk about graphs of sine and cosine. All right, so we're going to go ahead and start off with sine. All right, and I think we were using blue for that. No, were we using blue or red? Blue, okay. So we're going to look at blue for cosine. So we'll do red for our sine function. Okay, so keep in mind that sine from before are the y values on the unit circle. Okay, so sine is the y values on the unit circle. And if we go through and start at angle 0 and count all of the y values as we go through, we'll see that at 0 degrees, the y value is 0. And when we get to pi over 2, the y value is now 1. And when we go to pi, our angle or our y value is 0. When we get to 3 pi over 2, our y value is -1. And when we get to 2 pi, our y value is back to 0. Okay. Now you might be wondering, how do we get these other ones like -pi over 2, -pi? Turns out we just count the other way on our unit circle. And when we do that, we find that the graph goes down, back to 0, up to 1, and back to 0. Okay. Now, before we connect them, here's what we don't want to do. We don't want to connect them like with a bunch of straight lines like they're triangles, okay? Because if we were to plot like every single point here, we would find that it would be a lot more smooth, okay? Like this, okay? I'm going to leave that on the screen for a moment. That's what it looks like. And now let's go ahead and try and draw that, okay? So it's going to, curve is going to go up, going to come back down all the way to -1, go back up to 1, come back down to -1, and then we get to 0. Okay. Now the neat thing is this is going to keep waving up and down, all the way to positive infinity and all the way to negative infinity. Okay. Now, I do want to talk a little bit about the domain and range. So remember, domain is like all of the x values, and we have x values all the way to positive infinity and all the way to negative infinity. So the way we would write that is literally from negative infinity to positive infinity. Okay. All right, now the range talks about the y values, like what's the lowest y value that you have and what's the highest y value that you have. We see that the lowest y value here is -1, right? The bottom of this bump and the bottom of this bump. And then we also see that the highest y value is like up at 1, like the top of this bump and the top of this bump, okay? So the way we say that is we say we're including, so we use the square bracket, from -1 all the way to +1, and we close it again with the square bracket. Okay, so the parentheses means we don't ever really get there, but the square brackets means we get to -1 and we get to +1. All right, now here's two new terms for us. Okay, one is our picture even, odd, or neither? Right, even means that it's very symmetrical on both sides, right? Odd means that from the origin, one side goes up and the other side goes down. Okay, so what we have here, this is an odd function, right? Now, the other new word I want us to take a look at is this word period, okay? Now, the period just means like how long does it take for one full wave to be completed? Meaning, like if I start here at 0, I'm going to go up, back to 0, all the way back down and back to 0. This is one full wave. One full wave, like how many x values is that? It goes from 0 all the way to 2 pi. So what that means is my period is 2 pi, okay? And we can write down for ourselves like how long does it take to finish one full wave? Okay. All right. So we've got our sign. It's the y values on the unit circle. We came up with this graph, and then we talked a little bit about domain, range, whether it was even or odd or neither, and the period. Okay. We're going to do the same thing for cosine now. So for cosine, remember that these are the x values on the unit circle. Okay. So if I go to 0, the angle 0, the y value or the x value there is 1. And as I work my way around the unit circle, when I get to pi over 2, I get an x value of 0. When I get to pi, I get an x value of -1. When I get to 3 pi over 2, I get an x value of 0. And when I get back to 2 pi, I get an x value of 1. Okay. Now, if we were to do the same thing, but count in the other direction, we would find that those x values looked like this: 0, -1, 0, and 1. Okay. And just like last time, we're not going to connect them with straight lines, but we're going to connect them with a nice smooth curve. And it should end up looking something like this. Okay. Now this is our cosine graph, right? It looks kind of wiggly, just like our sine. But one thing we might notice is like right at x equals 0, both sides sort of like they match, right? They both go down and then they go back up and then they go down, okay? What this means for us is that cosine is an even function, right? Let me see if I can get both pictures on the same page. So they're both wiggly, right? But the sine sort of like one side goes up, one side goes down, whereas cosine, that's very even on both sides, right? So that's really the difference, is one of them is even and the other one's odd. Other than that, the domain is the same. It's still going to be from -infinity to infinity. The range is the same because the smallest y value is -1, the biggest y value is +1, and it also takes 2 pi to finish one full wave, right? So look at this. This is one full wave, and that takes 2 pi. Okay, so let's write those out. We've got from -infinity to +infinity for our domain. Our range is from -1 to +1, and our period is going to be 2 pi for the same reason it was 2 pi up above. Okay. All right, so the good news is we really just need to know what they look like, all right? Most of the time, I'm going to give you a graph, or you'll be able to graph it on Desmos and then kind of use that to look at it, okay? So let's take a look at our example for this. So example 17 says the volume V of T of air in liters in the lungs of a running adult T seconds after exhaling is given approximately by this function. Okay, so we've seen functions before, but what might be different for us here is that we actually have cosine in our function. Okay, it doesn't mean anything different for us. It just means now when we are graphing this, it's just going to look a little wiggly instead of just being like a straight line or other things that we're used to. Okay. All right. So part A says use technology to graph the function, include a sketch of your graph below. All right. So again, I'm not asking you to graph it by hand. I want us to use the technology and to graph it that way. Okay. And more specifically, I'm telling you what the X values should be. So like the X values, we're going to start at 0 and we're going to go to 4. That's the part of the graph that we're interested in. Okay. So if you were to go to Desmos, it would look something like this. Okay. So we would go 2, 4, 3, 1, and then the Y values go from 1, 2, 3, 4, up to 5. Okay, so this y-axis is our v of t, our volume, and our x-axis is t for time. And if you look at your graph, it looks something like this. So it's going to start at 0, then it's going to go to 3, and then to 5, and then to 3, and then to 1. And so we end up with something like this. Okay. So we've got a graph. We can see that it's kind of wavy, which makes sense because we have a cosine. And so when I ask us to sketch a graph, like this is really all I'm looking for. I don't need you to do it like by hand. Use the technology, mark off any important points because that'll probably be helpful later on. Okay. All right. So we've used our technology to graph the function. Um, all right, now let's go ahead and find the exact values of v of 0, v of 1/2, and v of 1, okay? So all that means is that I'm going to use this function, and I'm going to plug in 0 for t, 1/2 for t, and 1 for t, okay? All right, so v of t is 3 minus 2 cosine pi t. And by the way, the fact that I see a pi here, that is a really good indicator that we are in radians. And that's the mode that we want to be in when we graph it and also when we find those numbers, okay? So I'm going to make sure my calculator's in radians, and then I'm going to find v of 0 is 3 minus 2 cosine of pi times 0. Okay, so this is 3 minus 2 cosine. Let's see, pi times 0 is 0. Now this cosine of 0, I can actually find on my unit circle, right? I can go to 0 radians and find the x value there, right? And when I do that, I get 3 minus 2 cosine of 0 is 1, right? In other words, I have 3 minus 2, or I end up with 1. Okay. You could also type that into your calculator, but that's a good way to kind of double check, like, do you know how to find the values? Okay. We're going to do the same thing for v of 1/2. We get 3 minus 2 cosine of, let's see, pi over 2. Okay, look at this. This is another nice angle on our unit circle, right? So, whoops, I can go 3 minus 2 cosine of pi over 2. When I go to pi over 2 and I find the x value, I'm going to find 0. So I really get 3 minus 0, or 3. Okay? All right, what's the last one we want to find? V of 1. So 3 minus 2 cosine of 1 pi. So I can go to my unit circle, find pi on the angles, and then find the x value there. And I believe we get -1. So then I get 3 plus 2, or 5. Okay. Now the cool thing is these also match up with our graph. V of 0 is going to be 1, right? And when I have 1/2 in for my time, right, I'm going to get the 3. And when I plug in 5 over here, I'm going to get my my y value at 1, right? And actually, I think I've drawn this graph wrong, and I really apologize for that. This is why we double check our work. All right, but I think what I meant to do was up to 5 and the 1/2. All right, this is looking more like the values that we got, right? So that, and then up to 1/2, 0. All right. Okay, so hopefully now this matches with what you had. So if you're sort of worried as I was going along why yours look different, make sure you're in degree or make sure you're in radians, but then you should have sort of two waves happening in this moment in time. Okay. All right, last but not least, it says find the value v of 1.3 to 3 decimal places. Okay, so we're going to find v of 1.3. That means it's going to be 3 minus 2 cosine of 1.3 times pi. Right? Now, this is not a nice unit circle number, so I can just use my calculator. I just want to make sure that I'm still in radians. Okay? All right. So I'm going to type this all into my calculator, and I get 4.176 as my answer. All right. But we don't want to just be people who can type things into calculators and get a number out. We want to actually know what that means too. Okay. So let's go back for a moment and read the question again. So V of t talks about the volume of air in the running adult's lungs. Okay. So what does that mean? Like this one means this is 1 liter of air in someone's lungs. This 3 is 3 liters of air inside someone's lungs. This 5 is 5 liters of air inside someone's lungs. And so what this means is that at 1.3 seconds after exhaling, the runner has 4.176 liters of air in their lungs. Okay? So we're not just finding things, but we want to make sure we know how to interpret our results and think about what they mean. All right. So my apologies for the mistake on the graph earlier, but hopefully this will match now with what you have. And that's it for 8.2. Come on back for 8.3, where we take a look at how all the calculus ties into our trig function.